it on this computer and I'll post it. Okay. Let's go back to my screen. All right. So I've got a domain now. Let's think about it. The length is 1,000 meters. It's 10 meters wide. Right now, this is one layer. The top is at 10 meters above something, let's say sea level. The bottom is negative 50 meters below sea level, right? It's one layer, okay? It has one row. So in the Y direction, it's only one row of cells. It has 10 columns. So in the X direction, there's 10 cells. So it goes 1,000 meters. It has 1,000 cells, or I'm sorry, 10 cells over that 1,000 meters. How long or how big is each cell?
$100 meters.
It's 100 meters long. How wide is each cell?
10 meters.
How tall is each cell?
60 meters.
60 meters. All right. So right now we're simulating a single row of cells, 10 columns long. Though each cell is 100 meters by 10 meters by 60 meters. All right. Okay. So if I wanted to have this puppy be an XZ slice, I might do something like, well, I want them to be a square. That's what we did in our, what did we do in our finite difference? In our Excel model, what was the model domain? Do you remember? I think it was 200 maybe by. Let me see, I say, depth of the aquifer is 100 meters. The aquifer length is 300 meters. Okay, but on the homework, so I'm going to make the length 300 meters. All right, because that's what the homework assignment says. The thickness in and out of the Y in the Y, I can make it be whatever the hell I want. I'm going to keep it at 10 meters. It could be 1 meter, it could be 0.1 meters, it could be 1,000 meters, doesn't matter. I'm going to keep it at 10. Okay, the top, I'm going to say is at sea level, and I'm going to say the bottom is at negative 100 meters. Anybody need explanation on that yet? If you do, don't worry. I'm happy to do that. Okay. I'm taking silence as I can proceed. Is anybody lost yet? That I've got a domain, it's 300 meters long in the X direction, it's 10 meters wide in the Y direction. And by setting Z top and Z bottom, I'm saying that the total depth is 100 meters. Are we okay? Okay. Now, if I want to simulate head distribution in the Z direction, I better have more than one freaking cell in the Z direction. All right. So I'm going to make this puppy 30 cells. So 30 layers. All right. That means how now, or I'm not, sorry, not 30. I'm going to do 10 because I want it to be even numbers. How high or how thick is each layer going to be? 10 meters. That makes sense, everybody? It's 100 meters from the top to the bottom, and there's 10 layers, so each layer has to be 10 meters. What would I change the number of columns to be to make these squares cell, or these, these cells square? How many columns should we have? Yeah, we have LX is 30, the total length is 300. So if we want each one to be 10 meters, we're gonna make 30 columns. 300 divided by 30 will give me a 10 meter. Okay, so let's look at this now. We're going to have a model domain. It's 300 meters long, it's 300 meters wide, it's 100 meters deep. There's 10 layers. So each layer is going to be 10 meters. There's 30 columns, so there's 30 cells in the X direction. So each one's going to be 10 meters in the X direction. There's only one row, and it's 10 meters wide. So I have a sugar cube set now of 10 meter cubes. All right, del R looks good. It is LX divided by the number of columns. All right, well, that should give me 10 meters. LY divided by the number of rows. That's going to give me 10 meters. Z top minus Z bottom. That's going to be 100 meters. Divided by the number of layers, 10. That's going to give me 10 meters. All right. Del is like that triangle. It means the difference. It's like a difference. So del V is delta Z. It's the difference in Z. Del X. Or, yep. Exactly. I could name them whatever I wanted to. Those are just convenient names for me to remember. And yeah, delta usually we just means difference. Okay. Bottom is going to be a vector that goes from Z top to Z bottom. All right, so 0 to negative 100 by the length is going to be n layers plus 1. HK, hydraulic or horizontal conductivity. Just going to assign it to be randomly 1 right now. Vertical hydraulic conductivity, I'm going to assign it to be randomly 1. Specific storage, 1e to the minus 4. Layer type, does anybody know what that's for? Yeah, so what layer type means is this is a confined aquifer. A 0 means confined aquifer. You can have a aquifer that's unconfined or an aquifer that's convertible. Yeah, there's a whole series. You got to go into the help and figure it but I think it's -1, 0, and 1 are the different values, and they correspond to different kinds of aquifers. For now, we're just going to stick with 0 because confined aquifers are the easiest to work with.
Is Lin space is counting by 11?
Yeah, let's so we're gonna do a few things here. First of all, I'm gonna I worked with Andrew on this the other day, but we're gonna do it right now. I don't want, I'm going to do this. Import PDB. Okay. And so I use PDB. I can't write more than 50 lines of code without using PDB. If I was a really good coder, I could do that, but I can't do it. So PDB is Python debugger. And anytime I write code, I always have to use Python debugger. And I'm going to show you what we do with it. So I'm going to set a breakpoint with this command. All right, so PDB stands for Python debugger. And this command right here, so we're going to import it first things first. And then this command right here is going to set a breakpoint. And what a breakpoint is it's going to stop the code execution at that point. And we're going to be able to query things. And then we can step through the code or the script one line at a time and query things. So let me run this puppy. All right, so it's run. And right now, it opened up a command prompt and we're at this line PDB set trace. So now there's a bunch of commands, but we could do things like, I might want to know what del R is. So I type in del R, it'll print del R, it's 10 meters. All right. I might want to know what del V is, 10 meters. Del C, 10 meters. All right, so we're cubes, 10 meters by 10 meters by 10 meters. Okay, so now let us get to Claire's next question. So the next thing I can do is to advance a line. I type in N, that means next line. All right, and it ran that line bottom. So now I can see what bottom is. Oh, I got a bug already. What happened? Something is wrong. I don't know what it is yet. Huh. Let me see. I don't know. At any rate, what linspace does, so okay, so PDB is giving me fits right now. Because when I hit next, it's not doing what it should. I'm not sure why, but what I'm gonna do here is I'm gonna cheat. I'm gonna put the breakpoint down here, and I'm gonna run it. And we can look at what bottom is. So what linspace does is it starts at 0 and it goes up. Well, it starts at, so actually, so to quit out of Python debugger, you type in Q. I'm going to actually go down here and let's use the help to figure out what linspace does. All right, so np.linspace, it creates a vector, evenly spaced numbers over a specified interval, start, stop, all right, over a specified interval. All right, so let's look at what I'm doing here to why we do linspace here. So the specified interval is z top and z bottom, all right? And I want 11 numbers. 11 numbers. Why do I want 11 numbers and not 10?
You need the 0.
Yeah, it starts at 0. And these are actually the node numbers. So these are the elevations of the top and bottom of each cell. So you actually need one more than the number of cells. Anytime you are defining the top and bottoms or the endpoints of cells, you need one more than the number of cells. So that's why there's 11 of them. Okay, so all this does is return this array from z top to z bottom by the number of layers. And if I run this again, okay, so now if I check out what bottom is, it's an array. It goes z. It's basically the tops and bottoms of all the cells. So the bottom of the bottom cell is -100. The bottom of the next one is -90, -80, -70. All right. Okay, so let's look at my grid now. Now it's a bunch of columns, or it's a bunch of single rows, all right, that are 30 columns long, but I've got a bunch of layers now. The left-hand side of each of these is a constant head, and the right-hand side is a constant head. So let me ask you this, is that the right, do I want constant heads on the left side and the right side of this domain? Where did we apply our boundary conditions on the XL problem? Right, what kind of boundary conditions were those along the boundaries? So there was no flow on the left and the right side and the bottom, right? And then we set a constant head boundary, where was that? No.
At the top?
Yeah, we had an equation that determined it, and it was at the top, right? So the default boundary condition, if we don't have anything, if we have a bunch of cells and they just end, then MODFLOW automatically, the conductance out of that cell is equal to 0 and it's a no flow. All right, so I want the left and the right side and the bottom, they can all just, they can have an I bound of 1. All right, that means they're just variably, the head will change there, but no flow will go out of the domain. So my I bound right now is wrong. And we're going to change that. So right now, I make this I bound, and I'm going to, first of all, let me just comment these guys out, and I'm going to run it. Okay, right now I've got this domain, and you can think about this. It's really quite clever. The way that Python prints it out, you're looking at the X in one direction along and the Z down. All right, and it's ones everywhere. What's important to realize is that at the edges of the domains here, it's no flow. So we want this top boundary to be constant head. So what is the, if I want this top row to be constant head, what do I want the I bound to be? What's the I bound for a constant head?
0, right?
No. What, let me ask you this one. I did it before. What were the I bounds for the boundaries? I don't think I bound of 0 is a thing. So if it's -1, it's a constant head, right? So I want the I bound when when my layers is equal to the top. -1 is the Python slang for the last in a vector. I think this will do it. And for every X and every Y. So let's run this and see what we get. It didn't work because it did it for my bottom row. So let's make this 0. All right, let's look at this guy. So now my top row of cells here, my top layer, I'm wondering, is that right? I think it is, yeah.
I think so, yeah. That's your
Yeah. So this is the top. So these will, so -1, that means this top layer is going to be a constant head, and then everything beneath it will be variably head. All right, so now we need to set the initial conditions. So they can be, we can start off with it being 100 meters everywhere. We want it to be 100 meters because that means that it's that the head is at least as thick as our aquifer. Now that top boundary, we got to set a value, and it needs to be a line. So our only difficulty here is assigning the values there. The trick will be calculating the X dimension of each one of these cells. I'm trying to figure out how to do this. in such a way that makes,
Would row number times del C work?
okay, so good question. Let's try it, but what would row number times del C give me? What would be the X location of my first cell then?
0.
0. What would the location of my second cell be?
10.
10. Okay, here's the problem. That's the left-hand side of the cell. The center of the cell, the center of the first cell is at 5 meters. The center of the second cell is at 10 meters. Does that make sense? These cells are like these 10 meter by 10 meter by 10 meter cubes. We can set the value at like the left-hand side of the cell, but what we really want is the value in the center of the cell. So I'm gonna
So plus 1/2
Yeah.
LY.
Sure. Because right now we have constant spacing, that'll work. So we could do this. It's gonna start with 100 plus let me think about this. I'm gonna do it this way. So top is equal to, I want it to be, there's a million ways to do it. I'm trying to figure out the easiest, most logical way that will not confuse everybody. I'm gonna do it as a loop. So I'm gonna go for I in n column. So I'm gonna loop over the columns, all right? In len n column. X is equal to let's see, do I want to go the full length? I go -1. Why did I go -1? Anybody know?
Otherwise, your array gets out, your index is out of bounds.
Yeah, because the array is 0 indexed, when I go to the final length of the column, I'll be past the index. Okay, so my X will be I times del C plus 0.5. Right? So when I is equal to 0, it'll
I
be
think plus 0.5 del C times del C. Because you have to add 5, right?
No, I want to add 10 each time, but I want my first one and I want it to be 5. So let's think about this. So when I is equal to 0, I'll start off at 0 plus 5. So my first location will be 5 meters, right? When I is equal to 2, my next one is my next middle point is at 15 meters. So when I is equal to 2, I'll get, or when I is equal to 1, I'll get 10 meters plus 5, 15 meters. Right? So this is going to give me the X location of the midpoint of every cell. We'll make sure that it works here in a second. So let's print X so that we know we're doing it okay. And now we'll say H sub X is equal to 100 plus, what is the slope from the homework? 0.5 times X, 0.05 times X. And now I'm going to go in here and I'm going to assign the value to an STRT. So this will be -1, number of rows, doesn't matter. Number of columns. Okay. So this is going to go in, it's going to say in the top layer, there's only one column. So my only column index is 0. And for, there's only one row, sorry. So my row index is 0. So for column I, set the value equal to H sub X, which we calculated here. Anybody need some further explanation here? So let me run it.
The first number needs to be 0 because didn't -1 do the bottom layer?
You're right, Claire. That's what we had to do here. You're right. So let's try that and see what happens. Oh, someday I'll make the transition to Python 3. Ah, no, this is the same problem that Andrew had. All right. Range. What's going on here?
N column is just a number, so it doesn't need a length.
Good on you, Claire. Okay, so look, first we printed our X's, 5, 15, 25, 35. That looks good. What's the last one? Is 285. It's not working. It needs to go all the way out to 295. That makes sense to people?
You didn't deposit anything?
All right, 295, that's working. 100.2575. That looks good to me. All right, I think we're good here.
Sorry, how did you get it to 295? Would you add?
I just got rid of this, the -1 range and call.
Ah.
Instead of -1. And the reason why is, I bet, is because range doesn't include the end point. And we could test that here. Start, stop. Yeah, so it goes from start to stop exclusive. So it doesn't include the stop point. So, so I didn't need that -1 is the bottom line. All right, time discretization. We actually don't need any of this stuff because we're going to make this as a steady state model. True. We'll call this model, call it Tothe. This doesn't really matter. I think the problem here is in the visualization that we have to get flow not at the but let's just get rid of the quiver plot and I think we'll be okay. Levels, we're gonna go to 100, 115. See, plot map view, I think that's not right. So let's do some exploration. Plot cross section seems like a good bet to me. I'm not quite sure how to specify the right one here. Line is a dictionary. Let's see if that runs. Well, what's it called? All right, so bottom line is this will have run if I can get it to plot. Got an unexpected keyword. Oh. Okay, we're real close now. Here's the heads. I don't know what my issue is here. Oh, the quiver. I didn't kill the quiver. All right, so the main changes we made. So here it is. This is the 2D cross-section plot. All right, so the main changes we had to make here were to the grid. All right. We had to change the grid so that it was a bunch of layers. All right. We had to change the initial condition. And the boundary condition such that the boundary was across the top of the model domain, right? The constant head boundary. We had to set that boundary to this line. All right. And then I said it was steady equals to true. And then the only other real change here was in I had to plot a cross-section view. Now there's got to be a way to get the flows for a cross-section. We should be able to make this a quiver plot, but I don't know how to do that right yet. Yeah, this is basically question 6. Use plot vector. I'm going to use plot vector. All right. So Claire, I think I helped on this one. I basically
Yeah,
did
the
it.
only place I'm getting stuck now is getting the plot to show up. So I think it has to do with the contour parameter stuff I have, but
Okay.
no, that's what I got. All right.
What did I do? Levels? Did you change your levels 100 to 115?
And
Did you change the extent?
del R divided by 2, LX minus del R divided by 2, del V divided by 2, Z top minus Z bottom minus del V divided by 2.
Okay.
And then for my times, oh, you just did 1. I did
Yeah.
100.
Just do 1 because it's only going to output 1 time since it's steady state.
Yeah, I get a plot, but it's blank, unfortunately. So. Plot figure. Oh. I bet I commented out some stuff that needed to be there. That's an easy fix.
Good. All right, I'm going to stop sharing
All right.
unless people want to keep looking at this screen. I'm happy to keep it up too. I'm going to have to boogie actually.
Okay.
So
Thank
I'm
you,
going
Peyton.
to stop sharing here. I will stop recording.